In 3, 2, 1.
You can see my slides.
Hello, everyone. So today we have Natalie Pistunovich. She is a developer in an Aerospike company. And if you didn't know about Aerospike, it is one of the fastest database in the world. It's written in C++, and it's a great database. Natalie is a lead developer here. She will talk today about machine learning, and when she is not doing any of this, she is wondering if there is a life on Mars. So I'm giving my mic to Natalie. So that's it.
Thank you. All right. So good evening, everyone. It's great to see you all. And it's fun. There's a small counter on the screen, so I can see how many people are attending. So I can imagine this is a crowd. So that's a cool feature. And I am here to talk about machine learning infrastructures. And everything started when a couple of years ago, I helped my friends to do an online challenge. And the part where I was helping is actually see how long it takes to solve this specific challenge, which is a Captcha. And what you need to do in this one is break this screen. So it's very easy. You do 0, 0, 0, 0, then you try 0, 0, 0, 1, 0, 0, 0, 2, and so on until you reach 9999, and basically brute force. But there is this Captcha, and with every attempt that you have, you need to also write the text that shows up, and obviously this gets in the way of trying to do brute force. So the way that this game works is basically every stage that you do, you receive kind of a tool that helps you for the next stage, and from the previous stage, the tool that you receive is this model for this machine learning model that the text was trained on. I had that, and I was able to do that, and I think that's a great time to go because I'll have to go for a language. And these steps: inspect the model, load the model, try to do an attempt by opening the cookie jar, the Captcha, predict the Captcha, to get everything from the first attempt, and then if you failed because the model made the wrong prediction, then you just try again with the same thing that you have before, and it's okay because you have the cookie jar open, and then eventually you break this, and I can say that this worked within 3 hours, and this was something that was part of the challenge, and I wrote about this in this in the Gophers Academy in 2017, the Advent blog, which is each day in December there is one article about Go, and in December 28th I wrote about this one, and you can also find the GitHub link code here. Feel free to take a second to take a picture, go and code and run. Make sure you don't install TensorFlow with the current version, because right now the findings are booked. But I am a machine learning engineer. I'm not a data scientist. I studied computer engineering. I wrote my project in university in Kuda. I was thinking of working in NVIDIA would be awesome because I love parallel programming. But in Berlin, there is no software, so I ended up working in a software company. And the first company where I worked asked me to use Go, and since then I never. I always say working with Go. I think that's an awesome language, especially because it has so many cool parallel utilities to use. And in the past, I gave some talks about machine learning. I gave some talks about infrastructure. All of them were around. And this talk kind of connects all of those parts together. And what I hope is that at the end of this talk, some dots will connect, and you'll be like, now I get this, now I get why, and so on. And you will come home curious enough to go and give us a try. And if you see cool about this, if you want to get updates as I upload the turning this part into a tutorial step, follow me on Twitter. I'll be sharing it all there. So what we'll talk about today is how to do ML, the infrastructure that's required for that, an example of a bare bones infrastructure, look at a handle, and then we'll do a wrap. And let's start with what is machine learning. According to Wikipedia, machine learning is the scientific study of algorithms and statistical models that computers use to perform specific tasks without using explicit instructions, relying on pattern inference, which is a subset of artificial intelligence. What is artificial intelligence? You can summarize it nicely with this slide. It's so many things. One of them is machine learning. Many others is natural language processing, training, supervised training, text, speech, whatnot. And according to Wikipedia, artificial intelligence is the intelligence that machines demonstrate, which is not natural intelligence that humans demonstrate. And this is referring to describing the situation where machines mimic cognitive functions such as learning and problem solving as humans do. Let's talk about how to do machine learning. So step one, define the problem. That is what you're trying to solve. Are you trying to translate a text? Are you trying to recognize a face? Are you looking at an X-ray scan and trying to see if there's any specific disease? And you define what is success. Is success the answer that 99.9% accurate? Is an answer under 100 milliseconds is the right, is an important thing? Is it okay to do 2-3 minutes, for example, in the health field? And then you gather your data. The data needs to be relevant to the task. So say we're translating text, make sure you use the right script. Don't use Arabic letters if you're doing English. If you are doing digits, make sure you're taking the Latin script, and again, not Arabic examples. And then you prepare the data. You clean it, you pre-process. So make sure that if you have face recognition, the blurry pictures are not there. You randomize. For example, if you do digit recognition, you don't want this to be 0, 1, 2, 3, 5, 6, because then the computer will learn that after 6 always comes a 7. And you split your data set. About 25% of it you don't use for training, but you use only for testing in the end. And 75% you're using for training. Choose a model. The model depends on many things. What is the learning task? Is it prediction? Is it recommendation? Is it recognition? Depending on the input type. Is it a string? Is it an integer? Is it an image? Is it something else? And possible number of categories. Number of categories is basically number of predictions. Then you have 10 categories. If you do text prediction, you have between 20 and 30 categories. If you do face recognition, you have thousands or maybe millions. And then you train the model by assigning random values, and then you predict the trained data. So just making random values, doing iterations based on the 75% of the data that you have. And then you take the remaining 25% and you see the performance. From here, many times you will fall back to either step 4 or step 5 and you change something. But once you've said, you move to stage 7 to do the tuning of the answers. And then you're good to go and predict. So is one of the tools that I really like to use for this. It's an open source software or even end-to-end platform for machine intelligence, especially for application neural networks. And it's made of 2 parts. You have a tensor, which is a mathematical representation of vectors and matrices from all kinds of dimensions, and you describe it with 2 parts. Data type, in string, and the shape, which is number of dimensions, number of value dimension, and your tensor through the graph. The graph is a representation of the model. It's made of nodes, which each one represents a mathematical operation, and the data, as it flows through the graph, undergoes mathematical operation, and at any point you can get the intermediate value, and of course get the result in the end. What I like about TensorFlow is that it's community and it's friendly for developers. Some specific things like AutoML that basically lands you in stage 7. All you have to do is drag and drop images and their predictions, and it does the rest for you. You can also use a TensorFlow hub, which is kind of like a huge repo for models. For example, people who complete a PhD and made an awesome new model, they would upload it there. You have access to download the model in a format that is easily embedded in your code. And of course, this is the you need to train having chosen a model. And of course, there's lots of black tools that are being used on top of TensorFlow. Okay, we talked about machine learning. Let's talk about infrastructure. This is a great article written in 2015 by a group of Googlers, and they discussed the problem of hidden technical debt in machine learning systems. Take a picture of this. It's open. You can Google and read the entire thing. It summarizes perfectly 5 years ago, still relevant to today, the problems of just slapping some hacked up infrastructure around the machine learning model. There is a lot more to machine learning than just implementing the algorithm. Actually, the code of the model itself is about 5% of the architecture or less. And the rest is the supporting systems. So configuration, the data collection, the verification, the service analysis, the process management, the monitoring, and so many others. I like giving hands-on advices. So let's take a deep breath, and we're going to dive through a list of tools that I can recommend use to your infrastructure. And I'm going to name as many open source tools, and all of them are in Go or have Go libraries, which means you can build your entire infrastructure for supporting a machine learning algorithm in Go. Let's dive in. First one is Hadoop. It's an Apache project, and it's of 7 parts. And the nice thing about it is you can like mix and match and whatever parts to build your backbone system. And about half of the Fortune 500 companies have a Hadoop ingredient in the systems for the purpose of processing big data. It's made of 6 parts, distributed file system, MapReduce, with the algorithm that basically minimizes the data set. There is the Hadoop command, and there is Yarn, which is used to manage processes and slowly being less and used. And if you want to look it up, it's all open source, an Apache project. And I want to give a heads up. The next slide, where I'm putting into context, is probably the most tricky slide in this presentation. It's a lot like comparing apples to pears, or papples, as they're called. So it's a lot of mix and match everything, because there's flexible definitions and many things are different. So the slide is about data lake platform. In case you're not familiar with the term data lake, you can think of it as a pool of all the data in the raw habit. So it's not structured into a database, and this is different schemas, different formats, text files and images and videos and whatnot together. This term was coined by Dixon, and its good explanation is the content is in its natural state. So finally, that all the heads ups, this is the slide. Data lake platform is probably one of the first ingredients for the infrastructure of machine learning, just because you need to process a lot of data. Some of the tools that are used for that is Azure Data Lake, Apache Spark, Apache Hadoop, Google BigQuery. Next is database. You can use any of those. You can use many other databases, but this is when you want to store your data in a slightly more structured way so that other people can access in a standardized, fast way. Data goes into a database. Next is the serverless, or function as a service. So you have your model and you want to serve it and you want to make it accessible. So you put it on as a serverless function. And those are some of the tools that you can use for this purpose. Next comes data governance. Governance is one of the not discussed enough topics, in my opinion, in machine learning. This basically is a general name for processing your data, making sure that you don't store credit card information if you don't have PCI compliance, and making sure that each team can access only the subset of that they're allowed. And that in case you want to open a part of your data set to do open source, you also share that all the no sensitive data is being shared and so on. And those are the companies that will do data governance for you. And of course, there is monitoring, which is incredibly important because you want to know that your system is actually healthy. Putting it all together builds the bare bones infrastructure. So this will together build now all the different parts of what I personally see as the most minimal infrastructure for a machine learning application. And this is covered in the that we just saw now. So now it's more of an architecture. Stepping point system is, of course, data. We said data is available in many different formats. So let's say we have Parquet, JSON, and CSV. And then the first thing you do on it is the data governance. So you do the most basic things to make sure that the data that should really not be in the system will go into your system. And my favorite example is credit information. If you're not PCI client, you should store. The reason that I mentioned that is because my previous workplace in the company where we did my audit year, and I tell you it's a headache. So to be able to store information, store it, is already work. And we work with hashes. Next is your data. The data went through first filtering, entered your system, you store it time in the raw in the data. So we have examples is Hadoop and you also store it in a more structured way in the database. The purpose of giving it a structure is actually fast access and also not making each engineer, each team trying to figure out how to access different parts of the data, but having a standard API. And then make a second step of data governance. The second step of data governance makes sure that the right team has the right permission. So for example, the system probably needs to be able to see all the logs to make sure that phone numbers or email are stored in the right way. But the engineers don't really need to see the phone number of each user in the system to make sure that it works well. So setting this permission, user permission level is one example of data governance second stage. Then you have your data ready and you feed it to the model. And it's important to say that you should version your data the same way that you version your code for all kinds of reasons. Let's say you had a model that the data science team worked on and made a new release, but it actually started performing less well. So you want to easily roll back to the previous model. You want that. Or let's say you trained it on your, and then one client left and said, please remove all my data from your systems. That means that the data that you use to train your model belongs to that client should also go away. If you don't have your data versioned, this will be really hard because you'll need to do retraining from scratch. If you do have it versioned, you just roll back to the relevant version on top of that. Now that we made a disclaimer about versioning your data, let's zoom in a little bit about the training part. And this lands us here in the how to ML flow. And this can be broken down to roughly two types of training, the static and the dynamic. So online training, offline training. And models, offline training means you all locally and you just upload it. And well, the biggest con of it, of course, it's very easy to build, it's very easy to test. The big of it is that it can only predict things you know about. And anytime you need to make an update, you have to retrain the whole thing, recalculate the whole thing, and re-upload. So updates is really a long process. On the other hand, we have a dynamic model, which is adapted to changing data and likely to make better decisions. You have to put all kinds of limitations because it can get computing intensive, it can get slow, and you want to monitor the performance of it one time in how fast and how accurate, and one time how many wrong predictions are there. So if it's a finance thing, for example, saying fraud, not fraud, the client calls later and says this was actually fraud, you have to make those predictions. Okay, so model training, and the step in our is the model serving. Serving is giving the output, and if we zoom in on that, it also has two parts. It lands us in this stage of the how to ML flow, and you can make it online and you can make it offline. Online basically means calculate all possible results and upload lookup table. Online is actually make all the predictions as you go, so you have an internal feedback loop, like the example with a client that made a correction to the prediction of the model, and it corrects the model in live. And the good part of it is that we can make predictions as new information comes in. My favorite example is a flower shop. Let's say that your flower has a model, tells you how many flowers you should buy when. And it knows that during the week there's this many flowers being sold, and as the weekend comes, you want to buy more because more people buy flowers for the weekend, they meet their family or so on. And the model usually says Monday, okay, buy less, okay, buy more. And then February, and on February 10th, and that's and then it will tell you to buy less because it's the end of the weekend and the beginning of the week. And then you see actually more flowers have been sold. February 11, even more flowers being sold. February 12, even more. Now, if your model is online and is dynamic, it will realize that there's an increase based on this feedback loop that you told it 3 times, oh, I ran out of flowers too early. It will make sure you buy a lot of flowers on February 15th and end up not missing out on the biggest profitable day of the year on Valentine's Day. The cons are, of course, this is compute intensive, latency sensitive, pretty much this you saw with the training. So you need to monitor that and put some limitations. The offline model, the cost of the inference is, of course, negligible. This is pretty much uploading the lookup table of all the possible results. And that's also another benefit, is that you can always have all the information pre-calculated before, so you're never going to get predictions. But the downside is that we can only predict the things you know. So this is our model. This is the most basic infrastructure. Is that enough? No. The most important thing, of course, is the money. You want to make sure your system is healthy. You want to make sure that the number of connections to the database, that the timeout is not too high. You want to make sure that the prediction time is within the SLAs that you have for your clients. And you want to make sure that the prediction correctness is a that you on. So now this is what is what is most bare bones infrastructure for machine learning applications. And in the next slide, I will show you a snapshot of the ecosystem. This is another opinion or another point of all the information, all the tools and fields that are available out there in this world of AI and machine learning. And you can see that there are so many more fields that you can focus on. For example, you have Hadoop in cloud, a whole category for that. You have SQL databases, NoSQL databases, NewSQL databases, graph databases. You have data transformation, data integration, of course, monitoring, and then you have things like AI and storage and data generation and labeling. You have things like cross-infrastructure and also analytics, and you have visualization and search and so on. And there's a lot more you can add. There's also end-to-end solutions, which is a kind of the opposite of the open source and only written in Go example that I showed. And it's all Go, so this is all TensorFlow, and it has tools for each step of the chain of infrastructure for machine learning, from generating examples to making sure that the statistical distribution of it is good, to validating it, to training it, evaluating, and pushing, and then it ends up in serving. And serving, the nice part about TensorFlow is that you have the regular serving, you can have serving dedicated for web, you can have dedicated TensorFlow for mobile and embedded applications. So if you want your washing machine, you can do this with TensorFlow as well. Now I want to show you a concrete example of a client or a huge company that we all know and love and probably use, that how they are using their infrastructure for machine learning to do fraud detection in payments. So they receive user ID, seller ID, and item ID, and a hash of a credit card whenever a transaction comes in. And this is a good amount of information. But as we know with machine learning, the more data points you have, the more accurate your prediction is, right? So what is take that information and run it through Aerospike, one time for the user ID, one time for the seller ID, one time for the item ID, one time for the card hash, and pull out each of those values, input feature vector. Input feature vector. It's a mathematical representation of all kinds of values. So say how the user registered. Our data science team says the threshold is over X, then they're more verified than not, so they get the value of 1. How long has the seller been registered? It looks like a new seller, so we're going to give it the value of 0. How many of all your purchases fraud in the past? Based on that, give it to a value of 0.7. And how often this credit card was reported? Never, so we're going to give it a 0. And basically, each question has this range between 0 and 1, and it gives a lot more data points to the model. And based on that, the model can make a smarter. So the way that they do this is, for example, they insert one time the user ID, and they pull out such an input vector. They insert the seller ID, pull out all the historic information about them. And all of them feed to the machine model. The machine learning model is responding with fraud, not fraud, based. So actually, they have a number, a calculator based on all the numbers from. Reminding you, this is how the feature vector looks like, just a vector of numbers, which is being fed to the model, and the model puts out the number, and the number is above, if it's above a specific threshold, fraud, if it's not. And there is monitoring on the whole system because it needs to meet requirements like, is the performance time fast enough? Is the prediction accurate enough? Have I been blocking transactions from users who are should not be blocked, and or have I been allowing transactions for users that were actually fraudulent, and so on? And this is one of the reasons that PayPal is using Aerospec, because they can do this fast enough to meet their SLA clients, because nobody likes when you buy online things, you want to type your PayPal and you want this loop to run 2 times, and that's enough. You're ready to go to the next stage. If not, you're probably going to refresh or just leave the website. Okay. This was most of the presentation. I was running a little through it because the timer is very stressful. It will finish faster than planned. So I hope this leaves more time for questions, because there's a lot of to do here, and I would love to the different slides and zoom in on whatever is most interesting for the crowd. Quick recap of what we saw today, so you can remember to ask questions about. We saw what is AI, what is ML, and how to ML, and we saw this slide that kind of summarized this nicely. We saw generally what is TensorFlow and why is it called TensorFlow. So your data is represented as tensors that flow through the graph, and each node of the graph comes as a mathematical representation, or can represent the mathematical part of the model. We know the difference between online and offline training and inference. So do you pre-calculate and upload once, or do you get live feedback? We saw an example of a bare bones architecture as I see it. And saw that there is so much more out there if you want to dive into any other specific part that was not mentioned in the bare bones example. And we saw architecture that is being used in production by a huge payment company. This is a quick reminder of it. So you get some information transaction from the website. You create out of it a lot more data points by generating an input feature vector, which you feed into the machine learning model that ends up telling you based on that information, is it fraud or not fraud? And if you should take away anything from this presentation, here are 3 data points. Machine code is about 5% or less of the overall code of a system that is used in production for machine learning. The input data is big and it's a tricky part of a machine learning system, so make sure you give it a lot of focus. And the flow of what you'll do with that data is process it, store it, use it to train the model, serve predictions, and monitor the whole thing. Thank you very much. If anything interesting, please tweet to. Would love to. And that is it. Thank you.
Okay. Thank you very much, Natalie. It was really a mind-boggling presentation. So much information. Like I was like shocked. I was shocked by how much things are going on with ML stuff. I thought, well, you know, just take the data, put it in a model, and great, you have a result. But in fact, there's so much headache with all of that. And the question from me would be, well, you listed like 1,000 of different companies and tools to process that, but you know, I'm a simple guy. I just want to take something, click a few buttons that it should work. Is there any option that make life for developers simpler rather than complex and choosing the different tools? Maybe there are just, you know, tools like default ones that you should just go use and it will just work out.
The off-the-shelf solution would be just using TensorFlow extended. They have an end-to-end flow for that. All you have to do is give the data. And depending how much of that you want to do independently, or maybe as open source, or maybe pay less, in that case, you probably want to look at the basic example of web infrastructure and then just choose a tool of your choice. That's 1, 2, 3, 4, 5, 6 different components to your architecture. That's not so little, but that is considered the most minimal to start running in production.
Yeah, there is a question from Alexander Arlovsky. Why not Python? How Go helps?
You can, so to train a model, you can use Python. And Python is still the language for data science, the most dominant one, and building a model from scratch is Python. You can do this with any other TensorFlow binding, even though TensorFlow supports 10 languages, several bindings. For the part of the training, so not the serving, but the training, it's only Python. Why use Go in the infrastructure? Because it's really fast. It's really efficient. I gave a whole talk on why to use Go for your infrastructure, regardless of what your application does, unrelated to machine at all. Some part of it would be it's a complete language, so that's why you not use scripts. But also Go is just it has the dependencies inside, it has everything inside. You just generate one binary. You can give it to developers into infrastructure. You can cross-compile to different operating systems, right? Sometimes you work in a company where for Mac, one prefers Windows and one just likes their own specific Unix distribution. And Go is really easy with a cross-compilation for whatever the binary of the infrastructure is, so you can test always locally and you don't have to bother the system in, hey, this doesn't run on my machine. Go is in many times, especially in parallel processing, very fast in comparison to Python. That's another reason to use that. And personally, I think it's good to write in it.
As I understand, this is kind of more from corporate perspective. If you want to, to create something big, like some very serious, we have a very serious project. We need to do machine learning, invest a lot of money in that. But if I'm a geek and I just want to play around, build something, what would be the best approach to work with this machine learning infrastructure? Is there, could I do everything locally without these databases or something else?
Yeah, absolutely. You can train a database. You can train with the data you have on your machine locally, and then just upload that data. And say, hey, people, try my model. But then if you make any changes on that, you're going to have to go back to that folder. If you want to work with another person on that together, you're going to have to figure out how to share the data between you two, and that becomes a little cumbersome. So you don't need to be a big corporate. You need to be just even two people who try to synchronize something. Like, why would you write an open source code on GitHub and not save it locally, final version 1, final version? If you want to start sharing with other people versioning it, you need good tools to support that.
I understand it's like the ML on a higher level, company's level. It's like the code. You have to build a CI/CD pipeline of moving this data into this model, into this application that just does everything. So if we want to change something, we just click a few buttons and see the change. Otherwise, this ML process will need the person who originally created it. So the infrastructure
and their original data set, yeah, and maybe you need to change it again to be a format for training and.
Yeah. So if it's like the triggered approach, so we have to take this and transform this into this. Does it make sense to use like databases, services, and other stuff that use this on demand? So I don't want to, have like three services of error spike with a license running 24 hours a day just because one time I have to run something. Is there something on demand, which I say, this is my model. I want to pay $100 for each run, and it works out. So what for less frequent runs? Are there any suggestions on how?
Many databases offer services on demand on the cloud. I think most companies are moving to offer something on the cloud. Specifically Aerospike, while you can run the community edition for free locally, you don't need any particular license. It's still not on the cloud. It is going to be this year, and you can make it a cloud service if you want. You can. I guess it will be tricky to run every time a different database, just because the data modeling for each database is a little hard. Everything between databases always can be a. If you do something big, plan accordingly. If you plan to do just something local and small, you might get a pleasant surprise. Something is growing and it requires its migration. That pain to have.
There's a question from Miguel Brown. Any comments on the GoLearn ML library?
So I've mostly been using the Go bindings for the Go for TensorFlow. I have less looked at other systems out there. There's that. There's also several others that you can use. My personal favorite is TensorFlow, just because I've been using it for so long and I feel comfortable and familiar with it. I cannot compare. I don't know enough to make this comparison. So no.
So our Q&A session is going to an end. Just one last question from Luis. Would you use not only neural networks, but regression algorithms in Go?
You can use any algorithm because I find it easy to take the ready model for Flow Hub, depending on the task that I'm trying to fill. I might use that if it's just a use case. Yes, the problem mainly, but hub is where I go for that. So I'm going to find some model and try to implement that to take something because I find it comfortable as a engineer, a data scientist.
Thank you very much. So our Q&A session is finished. If you have any more questions to Natalie, please join her in a speaker's room. You could ask questions in person, have a nice talk. So it would be very productive there. So see you there.
Thank you.